Hello, everyone, and a very warm welcome to the Idea Mechanics Masterclass. I'm absolutely thrilled to have you with us for today's explainer. If you take a look right over there, you'll see our lead innovation catalyst standing by on the data screens. He's our resident expert, and today he's going to guide us through the exact architecture we need to completely transform our digital infrastructure. We've got a lot of ground to cover, so let's dive straight in. Today, we're tackling a massive challenge, bridging that gap between abstract ideas and practical, real-world execution, and we're doing it using TRIZ. Now, if you're not familiar, TRIZ is a highly systematic problem-solving methodology. We're completely shifting away from that old reactive mindset, where you just sit around hoping for a random eureka moment. Instead, as our catalyst shows us, true innovation is a highly repeatable process of discovery. It's a deliberate architectural skill that absolutely anyone can master. But first, we really need to address the villain of our story. Why are we so restricted by physical limits and incredibly fragile hardware? Well, this is what we call the physical hardware trap. For decades now, IT teams have been stuck in this endless cycle. They're constantly buying hugely expensive servers, fighting these rigid, inflexible limitations, and honestly just praying those single points of failure don't crash the whole system. We have got to escape this trap. If you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team.
And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ Principle or tech challenge we should tackle next.
Okay, here is our battle plan against those physical limitations. 1. The core philosophy. 2. The infinite canvas. 3. The invisible data center. And finally, 4. The unbreakable backup. Let's get right into part 1, the core philosophy, escaping the hardware trap. So the old way relies entirely on trial and error hardware. You buy a physical server, it costs an absolute fortune, it's totally rigid, and inevitably, it breaks. It's frustrating, right? But TRIZ Principle 26 offers us a systematic way out: virtual replication. It asks a brilliant question. How can we replace the expensive, fragile physical original with a highly functional, accessible digital copy? We basically construct these sophisticated replicas of real-world systems so we can scale effortlessly and with absolute resilience. It's a total game changer. Moving right along to part 2, the infinite canvas, the Metaverse. The big problem we faced here is a physical barrier. Building detailed interactive environments for global users in the real world, it's financially impossible. You obviously can't build a physical city for 1 billion people overnight. So what's the systematic solution our catalyst is pointing to? We use incredibly sophisticated computer graphics modeling to generate dynamic, virtual copies of real-world spaces. We completely bypass the impossible physical original and replace it with an immersive virtual or augmented reality experience, literally creating an entirely new digital ecosystem from scratch. Next up is part 3, the invisible data center, cloud computing. Our catalyst is highlighting a massive contradiction here. You have the need for incredible computing power, but it goes head-to-head with the massive capital expense of buying dedicated servers. A physical server is just a rigid piece of metal dedicated to a single app. But a virtual machine, that is a software-based hardware replica. It allows us to treat computing like a pay-for-use utility, drawing from a massive shared pool of resources. We are literally copying the hardware straight into software. So how exactly do we pull this off? Well, it breaks down into 3 really elegant steps. Step 1, you provision a shared physical infrastructure. Step 2, instead of buying a brand new computer for every single task, you create multiple software-based replicas, those virtual machines we just talked about, all living on that single server. In step 3, you consolidate, provision, and scale dynamically. You stop paying for idle metal sitting in a room somewhere, and you pay only for what your virtual replicas are actually using. And finally, part 4, the unbreakable backup, disaster recovery. Now, this is where Principle 26 literally saves companies from absolute ruin. Check out this timeline. In phase 1, we maintain continuous geographical data duplication, meaning we keep a live copy in a totally distant location. Now, phase 2 happens, say, a primary hardware failure or a massive cyber attack. The old hardware trap would mean a total catastrophe. But because we used systematic discovery, phase 3 immediately kicks in. We get an automatic switchover right to our replicated copy, which leads us straight to phase 4. Operations continue with minimal downtime. That geographic copy acts as the ultimate unbreakable failsafe. All right, let's bring it all together.
This is the core takeaway from our innovation catalyst today. The most resilient digital ecosystems are built by systematically removing the physical constraints of the original object. I really want you to internalize that for a second. True software innovation, it isn't some magical gift that just falls from the sky. It is a deliberate, highly architectural skill.
So I'm going to leave you with this final, provocative thought to chew on. Are you still out there fighting physical hardware, or are you ready to step up and architect resilient virtual replicas? Thank you so much for joining our community for today's Explainer. I really hope this masterclass leaves you energized and ready to implement Principle 26 in your own tech stacks. Remember, innovation is a repeatable process. We'll see you in the next one.